Hello everyone, this is James Shore with Let's Code Test-Driven JavaScript. You're watching The Lab, which is where we explore, experiment, and generally mess about. And today in The Lab, we're continuing our series on testing legacy code. This is important for everybody. You're going to deal with it at some point in your career. And as JavaScript becomes more well established, it is more and more likely that you're going to have to deal with somebody else's crap. In other words, you're going to have to write tests around other people's legacy code. So that's what this series is about. It's about understanding how to test and modify existing code, how to see it not as crap, but something you can actually work with. So thanks for joining me and welcome to the lab. What we're doing in this series is we're taking a look at intro.js. This is an actual project written by somebody else, by Afshin Marabeni. I hope I didn't butcher that name right now. What we're doing, this is real code. It's popular. It's large enough to be interesting. This is what the code looks like here. And what it does is it gives you the ability to do intros for web pages, sort of tutorials on a web page. It's a neat little project. And it doesn't have any tests. So what we're going to do is we're going to figure out how to test it. We're going to refactor it. We're going to put unit tests around it, all that good stuff. This series is taking place in multiple parts. In the first part, last month, what we did was we analyzed the code. We tried to figure out what the design of the existing code was. We figured out what our goal was going to be for refactoring it and what our test strategy was going to be. In part 2, this month, what we're going to do is we're going to get the code under control so we can refactor it, so we can make changes to it. We're going to set up automation and we're going to create pinning tests. These are not great tests that allow us to make sure that the changes we make to the code are not breaking anything. And then next month, and possibly in a part 4 as well, I'm not sure yet, we're going to actually do the refactoring and adding the unit tests. For details about the reverse engineering we did in the last episode, go ahead and take a look at that episode. But to just refresh your memory, what we did was we went through all the functions and sort of grouped them into their various pieces, and we figured out that the most important pieces of the project were probably the intro for element and show element functions. Then we decided what we were going to do. We decided what we're going to do is refactor show element because it is such a large function and it's doing the bulk of the heavy lifting for the project. We decided that we wanted to really focus on this part of the code. We also decided that we might want to add smooth scrolling of the step changes if we have time. It's always good when you're refactoring existing code to have a goal in mind. Don't just go in and try to change everything, but instead have something specific you're trying to deal with. And right now you can see that if the steps we're switching between are not both visible on the screen at the same time, there's this sort of awkward jump from one step to the next. And so we might fix that. I don't know if we'll have enough time in this series to get to that, but we'll pretend like that's our goal, if nothing else. We also decided on our strategy for getting that in, and that's what we're going to work on in this episode. First, we're going to get the code to build locally, just so, of course, we can make our changes and test them. We'll set up some basic automation, and then we're going to write a pinning test that runs this example right here, and just make sure that nothing has broken at each step of the way. And the way we're going to do that is by looking at the DOM and comparing it to what a known good DOM is. Now, a pinning test is not a great test. It's something that we're hopefully not going to keep around for very long, and so we'll take some shortcuts as we do this, but it should be good enough to tell us if we've done something that broke the code. And we might also write some tests around the animations, although I believe they're CSS animations, and that's not really our focus here, so we might not get to that. So that is the plan. We are going to get the code under control and write pinning tests. Thanks for joining me. Let's get started. All right, I've taken a look at the build that comes with intro.js, and because this is all one big file, all the build does is minify it. So I actually think that we can run these examples without doing any kind of special build, which is kind of nice. I think we just need to serve the example directory, or actually serve the local directory. And there's a little node module called HTTP server, which we can point at the local directory, and I think that will work. So let's go ahead and load that up at localhost 8080. And we'll go into the examples, and try running it. That is great. Okay, so I think we might be good to go here. I'm going to try changing intro.js in some silly way to just make sure that it shows up. Okay, here we are. We can change the default options. So I'm going to go ahead and serve that and reload it. And there's our change. Okay, that's good. That proves that we can actually modify this thing. Okay, so we do have the ability, we didn't need to write a build. We do have the ability to just run this, but I think what I'll do is I will add a Jake run target so that we can serve automatically. And I think I'll also want to set up a JS hint for linting. So I'm going to go ahead and do that, and we'll be back in a moment. Okay, I've got a basic Jake file set up here. It is set up to lint the code by default. It's using my simple build JS lint, JS hint runner, which is pretty straightforward. It just takes the list of files, some options and globals, just like you've seen in the other episodes where I've used JS hint. It's just packaged up now as an NPM module. The important thing here is that I went through and I suppressed all the errors. I didn't change the intro.js code at all because it's not under test. I didn't feel I could do that safely. You know, the weirdest things happen when you change code. Adding a comment could change something. If you change a critical piece of white space or the way semicolons are inserted, it's possible that adding a comment could mess something up. So I don't change the code at all until I have it under test. So what I did here is I just went through and I found all the errors and I suppressed them. Some of them were standard and some of them I had to take advantage of JS Hint's newish feature to suppress warnings by their number. But the net result is now I can run Jake and it will lint the code. So next I'm going to set up the local server so we can type Jake run and have that work. All right, I've added a Jake run command. So now I can go into my command line and say Jake run and it will start up a server. Then we can load that server here and go to the example directory and see intro.js working. So there we go. That is good. The way this is implemented is I just installed a local copy of HTTP server and then I shell out to it and run it in my build script. Pretty straightforward stuff, but this is, this is the kind of thing that's useful when you're dealing with legacy code. You want to get it under control. You want to get a little build automation in so that you can do what you need to do really conveniently. The next thing I'm going to do is I'm going to get Casper.js up and running so that we can start getting our automated test in. Now, I think I'm going to do most of the basic setup for this off camera. You can see the previous lab episode here to get the details of how Casper.js works. The challenge is going to be doing the part of Casper.js that navigates around the page and compares the DOM. So I'll be back when we're ready to do that. Okay, I have a basic Casper.js test running here. We can run Jake and it will run our soon-to-be pinning test. The way this works is in the Jake file, we've got the tests task, which will just turn around and call run pinning tests on our Casper.js runner. Casper.js runner is going to start our server using HTTP server. It's going to run Casper just by spawning the process, and then it will stop the server. And then when we run Casper, we tell it to look at this pinning tests file, which is right here or here. I've also made this test directory. And right now this isn't doing anything. We've just got it set up with a URL, telling it to start up that URL and start running, and then assert that the start button exists, which is this button right here. And as you can see, that does work. If I were to change this, if I were to look at just the example index instead, we would see that test fail. So there we have it. So now what it's time to do is it's time to actually get going on writing the pinning test. What we're going to need to do is somehow figure out how to walk through this example where we click here, then click next, then next, and then next page, and that. So first we'll get that part working where we click through it. And then second, what we're going to need to do is save off the correct version of each each step as we go. And Llewellyn Falco calls that approval testing, where we basically run the test, store out the information that we know to be correct, and then future tests check to see if it's changed. What we're going to do now is we are going to modify our Casper.js test to actually do something. And I think the way we'll do that is we'll start out by just writing Casper to do that progression without any assertions. And the reason for that is that this is not a simple test, and we've got to sort of dig into the way the DOM is set up to make this test work. So I think taking this in two parts, where first we get the test working and then we write the assertions, will be simpler. So we'll get the test working, we will manually verify it, so with manual verification, and then we'll add DOM checking, DOM assertions. And then what I think I'd like to do is check the test by breaking the production code deliberately. And that would be that. And I don't know if we're going to test this animation stuff. Specifically, what we're talking about there is when you click next, the stuff animates. And I think that's done in CSS right now, although I'm not 100% sure on that. And if it is, I don't think I want to try to test it because we're really just focused on the JavaScript here. Okay, the trick here, I think, is going to just be figuring out how to navigate through this and making sure that it's working properly. So I think what I'm going to do is I'll write a test to just navigate through all steps using the mouse. I believe the easiest way to do this, I'm just going to put it all in this one function. Pinning tests are throwaway tests. They can live a while, so you don't want them to be totally ugly, but at the same time, I don't tend to put as much cleanliness into them as I might into long-lived code. But that does vary quite a bit depending on how long I think the pinning test is going to stay alive for. This one actually might stay alive. If this was a real project, this might stay alive a while because it is sort of an end-to-end test that is generally useful. But to get started, at least, I think I'm just going to put everything, just get it done in a fairly messy way, and then see if I want to clean it up. I think the hard part is going to be making sure that this is working, I think. And so what I'm going to do is I'm going to start capturing out the state of the browser and just do some manual checks of how it looks. So let's say casper.capture pin.png, or better yet, delete me.png, and let's just try that and see what happens. And do we have delete me? Yes, we do, and we should be able to open it. And there is our page. That's good. All right, next thing we need to do is click the start button. And I think that will work this way. Then we should be able to just chain capture and maybe even chain the run. I'm not sure. Let's see what happens. Well, the capture isn't showing anything. And I'm not sure if it's because maybe we need to do it after we run through all the test steps. Okay, there we go. So yeah, we've got this showing up properly. Very good. Now we need to click the next button. And what is that called? Well, let's just go inspect it. It's called intro.js-next button. Okay, that didn't work, but I think we need to wait because there's an animation after the button's clicked. Okay, it looks like we can just do a then wait, and let's try waiting for 1 second. Now in a perfect world, I mean, putting timers in here is a recipe for race conditions. And in a perfect world, I wouldn't use timers. I'd look for something in the page. But this is the kind of thing that I'm not going to actually try to get right in this test because this is a throwaway test. it's the kind of thing that I'll just let go. Oh, and that worked. Look at that. That's great. Now that we have our test working and navigating through everything, what we need to do now is put in the assertions. And I think to start out with, what I'm going to do is just dump out the DOM. And I think the easiest way to dump out the DOM, I looked into this, I think the easiest way to dump out the DOM would just be to say, then basically just dump out the inner HTML. But let's ask, maybe Casper.js has a better way of doing it. So I'm going to look into that and I'll be back in a moment. Okay, a quick Google search got me to this article and it looks promising. So I'm going to just try it. And what I'll do is, I'm actually, rather than putting it here for now, I'm just going to dump out the DOM at the end. So I'm going to say Casper.then function like that. Okay, that's promising. Whole lot of stuff in there. Well, let's assume that's right for now. We can check into it more thoroughly later. So just to catch you up, what we've done here is we've got Casper.js clicking through the introduction. It's, pressing the button and showing the tooltips and all that. It's doing that. Now what we need to do is check the state of the DOM. What we want to do is make sure that our changes to intro.js don't break. And the way we're going to check to see if we've broken intro.js is by looking at the DOM and seeing if it's changed from a reference. So what we need to do now is we need to pull out the state of the DOM so we can save it off as a reference. So I guess what I'm going to do is I'm just going to say dump DOM, and this will be our function to dump the DOM. Yeah, well that does it. Okay, so what am I going to do with this? We've dumped it. I guess what I need to do is just cut and paste this into, we could store it in a file, but I'm not sure how to load stuff out of a file in Casper.js. And also, simple is better when you're talking about pinning tests. So what I'm going to do is I'm going to just grab this and cut and paste it. Oh, it's huge. Maybe I'll write it to a file after all. Okay, I'll check into that. Back in a moment. Great. That's just awesome. How awesome is that? Totally awesome. Way to go, guys. Oh, boy. All right. We have the first of these working. So let's take the file name here and let's put them in a directory called approvals, and we'll just dump all of these out. So this will be step 2, and this will be step 1, step 3, step 4, step 5, and done. Start as well. So start and end is what we'll call these. And let's see what happens. So this should just go through and dump the state of the DOM for every single step. And it should dump them into an approvals directory. And it did. Look at that. Now each of these is a megabyte. So trying to open them in the IDE doesn't look like it was a good idea. It looks like WebStorm did not like that at all. Regardless, though, I think we've got this. So I'm going to not look at these in WebStorm because it clearly doesn't like that. We've dumped them out. Now I'm not going to dump them out again. Now we'll write a function called checkDOM. What this will do is it will do exactly what we're doing here, except it's going to read the approvals and compare them. So this will be actual DOM, and the expected DOM will be fs.read tests approvals file name test dot assert equals actual DOM expected DOM, and then the message we'll just put in the file name. Now these are nearly megabyte each, so this could be bad. Let's see what happens. I'm gonna just check. I'm just gonna do the first one. All right, let's see what happens. Huh. That worked. Cool. And then if we click that and check step 1, that worked too. Huh. Interesting. This is a good sign. Let's check this in and then deliberately break it and see if it fails properly. So we've got that checked in. Now we should be able to go into here and do something silly, like change the next button to say foo. That should break this test because the DOM should be different. Oh, and it is. Look at that. That is awesome. It works. I mean, it kind of works. It's completely unreadable. But other than that, it works. So let's go ahead and go add to our list that we're going to want to make failures more readable. And the way we'll do that is we'll get a string diffing library. Okay, we've got our pinning test to the point where it is checking, it's clicking around in the DOM, it's loading the pre-recorded DOM from a file and checking it and seeing if it's the same. And that all is working really well. The problem is that when we run the tests, it's failing, and it's failing somewhat inconsistently. And that makes me think that what we're putting in the file and what we're getting from the actual DOM is changing from run to run in some way. But the output is so huge that we can't tell what's going on. And that's something that we're going to have to fix for making this usable when we actually are doing our refactoring as well. What I'm going to do next is I'm going to look for some code that will allow me to do a diff on this and just print out what's changed. So I'm going to go do that, and I'll be back in a bit. Okay, I'm back. Wow, it's been a day since I stopped recording, and I've spent probably 7 hours on this problem. Difflit, the tool that I was planning on using to solve the problem of having our comparisons look nice, it didn't work for 2 reasons. First, it relied on some node stream, so it just wasn't functional for our needs. But also, it had some fairly serious issues on it that haven't been addressed for quite a while, like a year. One of which would cause things to say they were the same if they weren't, if there was nested arrays. So that's pretty serious. So what I did was I wrote my own because, why not? I wrote a little tool called Big Object Diff, and I did not want to do this. Believe me, I did not want to do this. But in my research, I couldn't find anything that did what we needed, which is comparing 2 very large object trees and showing just what's changed. And so that's what Big Object Diff does. It's on NPM. You're welcome to use this in your own projects. It will dump out only the things that have changed. So if we come into here and we run our tests, right now they're all passing. Although I did discover that they're not totally predictable, and that's because we're capturing some stuff that we don't need to capture, like the window size, which apparently Casper sometimes gives you a different window size for an unknown reason. At any rate, if we change something about intro.js, like change this to foo rather than next, and we run our tests, as you've seen, this results in just absolute disaster. There is no way for us to tell what went wrong. Now here we know what we broke, so it's not so bad. But we need some way, when we don't know what we've broken, we need some way of seeing that. And here we just can't. So that's where Big Object Diff comes in. So I'm going to go ahead and install that. And the way it works is you'll just say install Big Object Diff. It's just an NPM module. Save that off. And I will go ahead and get that in and be back in a moment. Okay, what I've done here is I've required big object diff and then called render diff on it. That compares the two DOMs and returns the differences in a string. If the differences is not an empty string, then we log it out and fail the test. If they are the same, then the differences will be an empty string. So let's go ahead and try that and see what happens. That is still pretty ugly. It is working. You can see the brackets from render diff coming out here. But what's happening is we're getting the outer text and inner text of each element. So that is an inner HTML as well. And that's not good. What we really want is to ignore those and just look at these sorts of things. So you can see, I mean, eventually it gets to the point where it's useful. All right, well, I think what I'm going to do is I'm going to go back to big object diff and try to make it a little more helpful because we're not quite getting what we need out of this just yet. Back in a few. Okay, I'm back. I've made a couple more revisions to big object diff. Now it's collapsing objects and also it's truncating long strings. So hopefully that will be helpful when we're dealing with those inner HTML lines. So now when we run this, we should see more clearly what's going on here. And yeah, it does look like we are. I don't know exactly what the problem is, but it looks like what we're getting is we're getting more children out of this, both in the CSS and here. And I think the way to resolve this is in our pinning test, rather than pulling out the entire document, let's just pull out the document body, and that should help quite a bit. So I'm going to go ahead and pull that out. I'm going to go ahead and rewrite the approvals, and we'll see where that gets us. These approval tests can be pretty brittle, especially, well, pinning tests, not necessarily approval tests, but pinning tests can be pretty brittle, which again is why we don't want to keep it around. But this is the fastest and I think most effective way to get what we need, which is, again, just sort of nailing down the behavior, the current behavior. So let's see if we've got this working. Now these approvals, oh, that didn't work, darn. Okay, I think I've got this. It occurred to me that maybe the process of converting the JSON to a string was removing information that we are comparing against. So what I'm going to do here is I'm actually going to normalize the DOM by converting it to a string and then parsing it back into an object. And hopefully, and then I'll rewrite the approvals. And hopefully this will solve it. This kind of stuff is typical for legacy code, by the way. I mean, that's why I'm doing this in multiple parts, is because it can take a long time just to get the pinning tests in place. It can be a real bear. But hopefully once we get this working, then it will be much smoother. Then we'll have all the challenges of actually refactoring the code, but at least we'll have the tests around it. So as I said earlier, this part, before we even doing the refactoring, getting the test around is often the most difficult and really worth doing. Well, so far so good. This is where it would crash before, or fail before, I should say. Okay, I think we've got it. So we've modified the approvals to normalize the DOM and only look at the document body, and I think that's got it. Now, we may discover as we continue to work with this that it's not reliable, and we'll just burn that bridge when we come to it. But for now, I think this is good. Okay. Well, I've said this a million times, but the pinning tests, they are a hack. That's why we don't want to rely on them long term. That's why we need to refactor, get some proper unit testing. And also, this is one test and it takes forever. So the unit test will go a lot faster as well. All right. Now that we've got this working, let's prove it. Let's do something a little wacky. Let's try just randomly breaking stuff. See what happens. Oh yeah, good. Okay, what's next? What if we take this out? Good. Let's do something a little tricky. Here, we'll set the tooltip text. Yeah. What if we changed this to be, I don't know, a plus? Good. All right. This is why it's called a pinning test. We've nailed it in place. This should be easy if we change the class name. Yeah. What about an off by 1 error? Let's try changing this to less than or equal. Oh yeah. Blam. Did not like that. What if we make this start at 1? Boom. Blows up. Okay. Let's try doing less off by 1 error a little bit differently. Oh yeah, that kills it. Okay, what else can we do here? I want to do something nasty. This one might work. I don't know if we've actually set this option, so this might not break. Nope, it does. Good. What about this next tooltip button? Let's do an off by 1 there. Oh, that's working. Yeah, that's working. So the pinning tests aren't perfect. We're still going to have to be really careful as we're doing this refactoring. But as you can see, it is catching quite a bit of stuff. So that is pretty cool. And like, for example, we're never calling previous steps. So we're probably going to want to go through and actually update the pinning tests as we're doing the work, just to make sure we don't break anything. But as you can see, it does catch quite a bit of stuff. Oops, well, that will just result in a syntax error. There we go. Yeah, so it does catch quite a bit of stuff. It's not going to catch everything, but there we have one test that's really doing a good job of catching most of the things that can go wrong. Not everything. I'm not sure if this one's going to get caught because it was sort of in a special case. Yeah. But most things. So what we'll do is when we start doing the refactoring, which will be in the next episode, we will double check things as we change them and maybe add more tests. And that brings us to the end of this part. We're going to continue this next month where we'll start doing the refactoring. Now, just to remind you what we've done here, in part 1, we started out by reviewing the code and reverse engineering the high-level design, getting a good sense of what the design of intro.js was. We decided what we were going to work on, and what we decided to do was refactor show element, one of the larger functions in the intro.js module. And we also figured out how to test it. We decided that we were going to put pinning tests around it that focused on making sure the DOM didn't change as we changed our tests. Then in this episode, we got the code to run locally, added the Jake run target and set up some automation. And then we wrote that pinning test. That took a lot of work. And the main way it works is through approvals. We're using Casper.js to click through the intro.js workflow like this. And we're writing out the state of the DOM at each step. Then using the new library I just wrote called BigObjectDiff to compare that against a known good version of the DOM that we had previously written out. Next time, we'll take these pinning tests. We might expand them a little bit to include keystrokes, and we will start working on refactoring intro.js and improving show element. I'm looking forward to that. Now that we've got the pinning tests in place, we can actually start doing the refactoring. There's a lot of stuff to show you there as well because refactoring legacy code can be a challenge. So stay tuned next month when we continue this exercise. Thanks very much for watching, everybody, and I will see you next time.